Hi students, welcome to our channel. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In this session, we will see the NumPy library in Python. Overview of the presentation. So first, we see introduction to NumPy arrays. After that, we see how to access array elements. Then we will discuss about slicing and indexing. And finally, we will see reshaping and flattening arrays. Outcome of this lecture: at the end of this lecture, student will be able to understand how to efficiently handle multi-dimensional data in Python, apply reshaping and flattening techniques to solve array manipulation problems. Introduction to NumPy. So NumPy means numerical Python. So numerical Python is a powerful Python library for numerical and scientific computing. It provides n-dimensional array object and D-array for fast and efficient data storage. So mathematical functions to perform operations on arrays. It supports for linear algebra, so Fourier transforms and random number generations. Why NumPy? Now, so NumPy means it's an array. So simply in Python, by using the list also, we are going to do the array operations. Now we see what is the difference between list and NumPy. Why NumPy is important while you are handling huge amount of data sets. So lists in Python are flexible but slow for large computations. So NumPy arrays are faster, memory efficient and optimized for vectorized operations. So let us see why lists are slow when comparing to NumPy. In this program, list 1, list 2. So list 1, the numbers 0 to 9. So this is the list 1. Similarly, this is the list 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the two lists. Here I am taking one list known as result. In this list, I want to store the numbers, addition of these two numbers, 0 plus 0, 0, 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, 4 plus 4, 8 and so on. Okay, so now I want to show the difference between list and NumPy. If you observe, the list is also seems like array only, but I want to show the difference between list and NumPy in terms of execution time. Now if I execute this program, okay, so this is the expected output. So two lists, this is the list 1, this is the list 2, so this is result list. Here I am taking one module, time module. So before computing this result, here I am taking two variables, start and end. So before this computation, I will store the time in start. So after computation, I will store the time in end. So the resultant time is end minus start. So let us execute. Okay, if you observe here, this is the time 0 point, this is the 10 power, so this is 10 power minus 5. So here we are taking only 10 numbers, so it takes 0.0000104 seconds. Now here the data is very limited, so I will change the data to 1 crore. Okay, here I am deleting these print statements. Let us compute. Okay, so now so time taken is 0.6 seconds. So let us execute for 10 crores. 0, 0. Okay, So let us compute the time, how much time it will take. It is 7.5 seconds. Okay, now the same program, now note this value. The same program we will execute with the help of NumPy. Same program write with the help of NumPy here. Let us execute. Here this is the 10 crores. Let us execute this program using NumPy. Now if you observe the same problem, the time is 0.21 seconds. So previously it is, while using the list, the time is 7.5. Now it is 0.2. Okay, I hope now you all are understand why NumPy arrays are faster, because it is memory efficient and optimized for vectorized operations. Vectorized operations means the row wise and column wise you are going to apply some mathematical operations. So these NumPy, so widely used in data science, machine learning, image processing and in scientific simulations. So let us see the features of NumPy. It's an efficient n-dimensional array object and array. So faster than Python list, supports vectorized operations, because if you are performing the same operations on list, there we are going to use loops. Here we are applying on rows and columns, that we call as a vectorized operations. Provides built-in mathematical, statistical and linear algebra functions, and works seamlessly with libraries like pandas, so matplot library, TensorFlow and scikit-learn. So now we see how to create arrays using NumPy. So to use NumPy, so first you import the package into your program by using import keyword. Import NumPy. So for this we give one alias name. So NumPy as NP. Now onwards we can call this package with the name NP. Now we see how to create 1D array. So this is the variable arr1 equals to np dot array. Here you can give the numbers. Now if I print, it will print 1 2 3 4 5 as output. So this is 1D array, only row wise. So creating 2D arrays, np dot array, you can give these 1 2 3 as a one list, so 4 5 6 as another list. So 1 2 3 is a first row, so 4 5 6 is second row. So let us see some array attributes. So these are the different attributes available. Shape means it will return rows and columns. N dimension means number of dimensions. Size means it will return total elements so present in the array. Now D type means it returns data type of elements. So for example here, so print arr dot shape. So previous example, so this is the arr. So 1 2 3 4 5 6. Now if you print the shape, how many rows? 2 rows. How many columns? 3 columns. So it will display 2 3 as a output. So print arr2 dot n dimension. How many dimensions? 2 dimensions, rows and columns. So print arr2 dot size. So total elements present are 6. So data type of arr2, it will return int 64. If your system is 32 bit, then it will return int 32 as a output. Okay. Array creation functions. We have different functions available to create arrays in NumPy. So one is np dot zeros 2 comma 3. Now this zeros function will create with zeros. So for example here I specify as a 2 comma 3. So it creates 2 by 3 array. It will create 2 rows, 3 columns. So all are filled with zeros. That's it. Okay. See np once 3 comma 3. Now it creates 3 by 3 array. 3 rows and 3 columns. All are filled with 1. So next, arrange 0, 10, 2 means it creates values from 0 to 10. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 with step 2 means 0, 2, 2, 4, 6, 8, 0, 2, 4, 6, 8. With these values, it creates one array. NP dot line space. So 1, 5 means it creates 5 evenly spaced values between 1 and 5. 1 and 5, I want to create 5 values. So here it will create evenly spaced values between 1 and 5. So NB dot I3, it creates 3 by 3 identity matrix diagonal of ones. For example, here I am specifying as a 3 by 3. So it creates 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now say NP dot zeros 2, 3 means a 2 by 3 array of zeros. So NP dot 1s 3, 3 means it creates 3 into 3 array of 1s. NP dot arrange 0, 10, 2 means it creates one array like this 0, 2, 4, 6, 8. Line space 1, 5, 5 means it creates evenly spaced values between 1 and 5 as 5 numbers 1, 2, 3, 4, 5. So print NP dot I3 means it will create one 3 by 3 identity matrix. Let us execute these instructions. So this is the 1-day array creation. This is the 2-day array creation. So let us execute these. Okay. Now, so this is the resultant. So 2 by 3, 2 rows, 3 columns, all filled with zeros. 3 by 3, all are ones. So this is the arrange 0, 10, 2. So this is the line space 1, 5, 5. So this is the identity matrix. So let us check this line space. Here I am giving 10. So let us execute. Now 10. So this is the resultant result. So 10 numbers. Okay, between 1 and 5. So 1, 1.4, 1.8, 2.3, 2.7, 3.2, 3.6, 4.1, 4.5, 5. Array operations. So we are going to perform array operations like addition, subtraction, multiplication, power. That means here I am taking A, B. A is 1, 2, 3, B is 4, 5, 6. Now A plus B means 1, 4, 5, 2, 5, 7, 3, 6, 9. A into B means 1 into 4, 4, 2 into 5, 10, 3 into 6, 18. A power 2, that means A apply power 1 square, 2 square, 3 square. Okay, so it will return 149 as a output. Mathematical functions. So these are the mathematical functions: square root, mean, max, min, sum. So here I am taking a variable ARR with numbers 1, 4, 9, 16. Now I want to find the square root of all these numbers. How? Use np dot sqrt ARR. Now it will return 1, 2, 3, 4 as a output. Now mean, it will return average of elements. So average of all these values 1, 4, 9, 6. The mean is 7.5. I want to find the max value in this array. Then I am going to use max function. I want to find the minimum value. Then I am going to use the min function. I want to know the sum of all elements. Then I will use sum function. So let us execute these functions. So this is the array 1496. So this is the resultant of these functions: square root, mean, max, min and sum. So now we see indexing and slicing. Here, so this is the one dimensional array ARR 10, 20, 30, 40, 50. It is similar to lists only. Now ARR of 0, this is the 0, so it returns 10. ARR of -1, negative value, so the last value we are going to print, so it prints 50. So 1 to 4, so it returns 1, 2, 3, so it is 20, 30, 40. Now we see, so how to indexing and slicing in 2-dimensional arrays. Here mat, so multi-dimensional array is so 10, 20, 30, so 40, 50, 60. Now MAT 0 1. So 0 1 means this is the 0 1 0 1 2. So 0th row first column, that is 20. So it will return 20 as output. So mat column 2. So column means all the rows. Here column specifies all the rows. So 2 specifies second column. Second column is, this is the second column. In second column all the rows 30 and 60. So this is the output. So next one, print. So mat 1 comma column. Column means all the columns. So 1 column, that means the 40 50 60. Okay. So next mat column means all rows 1 to 3. So here 1 2. So it prints 20 30 50 60 as output. Okay. So let us execute these functions. So this is the print ARR of 0. So it prints 10, ARR of -1 50, ARR of 1 colon 4 20 30 40. So here for this mat 0 comma 1 20. So mat hyphen mat column means all the rows. 2 means second column. In second column I want to print all the rows, so it prints 30 60. So similarly 1 column. So 1 column means 1 represents first row, column represents all the columns. So it prints, so 40 50 60. So next column 1 column 3. So column means all the rows from first column to third, that means 1 2. So it prints 20 30 50 60 as a output. Reshaping and flattening. Reshaping means converting 1D array into multi-dimensional arrays. So flatten means converting multi-dimensional arrays into one-dimensional arrays. So reshape means converts 1D array to multi-dimensional. Example, so 2D 3D. So flexible shapes, but total number of element must remain same. So flatten means converts multi-dimensional into one-dimensional and always returns a copy in flat array, that means 1D array. Now example, here error NP arrange 1 comma 7. Now 1 comma 7 means this is the array. Now I want to reshape this as a 2 comma 3. How? Reshape. What is the 2 here? 2 means number of rows are 2. 3 means columns. Number of columns are 3. So it becomes 1 2 3 4 5 6 and stored in a variable mat. This is the mat. Okay, so now if I print mat, this is the output. Now I want to flatten this mat, this multi-dimensional array. How? By using the flatten function. Now this 2D array will change as one-dimensional array 1 2 3 4 5 6 and assign to a variable flat. Okay, so this is how we are going to reshape the arrays in NumPy. So let us execute these functions. Okay, so last 1 2 3 4 5 6. This is the 2D array. So this is the mat here and so flat. So this is the 1 2 3 4 5 6. So coming to summary of the session. In this session we learn about NumPy, so numerical Python library in Python. Now so NumPy means the fast numerical computing library. It supports arrays. We have different mathematical functions. So this makes the Python code faster, simpler and more powerful. I hope you all are understand the NumPy library in Python. If you have any doubts, so place your doubts in comment section. I will answer all your doubts. So thank you.